So this is a HT1250. A friend of mine asked me to look at it. It was one of my, kind of the original group of 1250s we did. And it has an odd problem. Battery's good, it won't power on. But with the battery off, now it will, should power on. There we go. It'll power on. And problem is when you have the power switch off and the, let's see, power switch off, battery off, and you connect the power switch, it'll boot and then immediately power down. And let's see, the power on, power switch on. Okay. And what's strange here, you see now it powers off. So there's something definitely wrong with this, and I'm gonna have to open it up and figure it out. I'm hoping it's just something simple related to the power circuits. Typically it is. I put this on. This wasn't on here when it came at this. The battery and the antenna is. I just got the brick of the radio itself to test with, but that's fine. I mean, I have all this stuff, and you know, everything's charged. So I will give it a check, I guess, and see if we can figure out what's going wrong with it. Hopefully, it's simple. Well, the something is messed up on this. The speaker is not outputting on the flex. I don't know what's wrong. I'll have to look at it. But this is in your original flex. This is it here with a donor. This has an LCD problem. It's sometimes it works, sometimes it don't. But there you go. You see, you got audio output. But problem is LCD is off, and it works now because we removed a part that was that right there, which when the radio goes into boot mode, it puts it overrides the switch, basically makes certain that we have unswitched B plus to switched B plus, but it only does a little bit. And the problem is right now, whoops, it just reset itself because it fell. But you know, as you can see, it's got your shit in here. The problem is, steady state, it's drawing 0.22 amps. No audio output, no nothing. That's a real fucking problem. This should draw 0.05 amps or so, and you know, without any receive. So something in here is drawing a lot more power than it should, and that's probably why that switch failed. Because even if I turn the power off, now it's shutting off, which is good. But when I turn it on, it's drawing a lot more power than it should. That's going to kill the battery. I don't know why that is. So that's another problem. Well, we finally got this back down to drawing a seen amount of power here. It's powered up right now, so let me get my poker here. So there was definitely some ESD. There's, you know, obviously parts that have been moved here. I had to put a resistor in there to measure current. I have the audio power amplifier off of unswitched B plus. That's the power control IC off of unswitched B plus. One of the ferrite beads that's there, decoupling the power transistors. Checked all this stuff out. There's a separate line here that I have set up on this to bypass the MOSFET. And here's the great thing. So mine reads 58 milliamps when I have it on. This one's 59, and that's 8.4 volts. That's exactly what we want to see. You can see some of the it's on the LCD there. put it like that. You can certainly see it. Let me flip this over and I'll show you the other side. You know, what's funny is the LCD requires basically no power until the LEDs come on. It's pretty funny. And oh yeah, you know, of course, had to get multiple shields off, all kinds of stuff. It's a pain in the ass. So, in this case, this is a battery-powered radio. And this is it standing by. It should draw about 60 milliamps, somewhere in that neighborhood, anywhere from 50 to 60 at 8.4 volts. As the battery voltage goes up, it'll draw a little bit less, just because that's what it does. So this is the meter in its lowest range. You can see the CDM, or the HT1250 is drawing 169, and it's going down a little bit here, microamps of DC. That's because there's one regulator on the board here that is an ultra low power regulator that stays powered up the entire time the battery is connected. Right now I have the battery set to 8.4 volts, which is kind of a full charge, pretty close to it, for the lithium pack that it uses. And let's see, looking here, see the regulator right there, and that's on unswitched B+. So that is feeding this, and you can see it charges the lithium ion battery that's in there. When it turns on, that Q416 there kicks on and will actually power right there. There's your standby voltage. That's enough to keep your clock oscillator down here, which is this crystal. You can see right there oscillating, and that's what keeps the real-time clock working. So in this case, RTC wasn't working. It turned out to be that FET was actually bad, and now with it replaced, you can see that's what we have there. Interestingly enough, I'll go ahead and I'll take the battery out here, and let me just show that. Let's see if I can zoom in. So of course, there's the battery. And if I pop that out, come on. So there we go. Okay. Actually pretty hard to pop it out, just doing it one-handed. And let's go back up here. Now you see we're drawing basically nothing. So, nothing at all. And if I pop that back in there, pop that back in, you'll see it'll immediately start charging, because this is a pretty dead battery. And it'll quickly start going down because it's going to consume less current as it gets charged up. But that's the battery circuit, and that's was the last and final thing here to repair on this. It was kind of tricky. I don't know what happened here, but this is definitely some ESD, is what I'm thinking. Anyways, and there was a whole bunch of problems with the. You see, I'm still missing a few parts there. I gotta fix some stuff here. But there was definitely several problems. But I had to go through and actually start pulling stuff off the bus, and it turned out to be leakage across this one part here. So this is unswitched, and then when you turn the switch on, there's your mechanical switch right there. Basically what happens, it sends a pulse out. There's a RC time constant here. This turns on for about half second or something, conducts up here, causes this thing to conduct, and it's going to ground this. And this is a FET. It's basically a low resistance switch. It connects unswitched to switch and turns on all the regulators and everything. This is what makes 3 volts. VDD is what powers the chips and everything. Anyways, so after a half second, all the chips are powered up. This chip here sends a signal through here, and you see these 2 diodes. It can go this way, but it can't go back through this, and keeps it turned on. So the mechanical switch doesn't keep it turned on after that time. What was happening here, even though this tested good, and everything was working, I was still passing, there was enough leakage while this was on, and what'll happen here is if there's leakage back this way, it'll find ground and ground out through this device here backwards across it. And that was causing an extra 35 milliamps of draw, a very small amount, but enough to run down the battery much faster than it normally would. And that's basically it. You can see it's pretty small stuff. I got my scope set up here, and all it was that part right there. But because of the way it was and the way this is configured, I had to go through and basically remove almost every part that was hanging off the unswitched voltage to see what the hell it was. I was kind of barking up the wrong tree for a little bit. Normally, something like this, it's used, and by the way, you can see there's those shields that go over there. Those were fun to get off. Normally you wouldn't bother with something like this, but this is actually a 220 megahertz version, so it's pretty rare, and it's just the frequency band that it's in. You can see over here is a UHF one that I took apart. There's 16 shields on this, and it is a true pain in the ass to get it apart. But I did this so I had a known good one that was working and could test with, basically. Okay, well, I have everything fixed here. Again, this was a 220 megahertz modified for the amateur radio band, HT1250. And it works. You can see it's got several of the shields removed because multiple problems with it. Definitely some electrostatic discharge or something hit it. Not exactly certain what it was. It was a soft failure of several regulators over here. There's a 3-volt regulator there and there. Actually, as a matter of fact, I'll zoom in here and you can see it. Okay, so in this case, we're zoomed in here. That is a switching FET that handles the backup battery. There's a lithium-ion backup battery built into this. You can see the crystal there. That there is a resistor that feeds the VDD into this device, which is the CPU. I changed that out just to be able to do a current reading. Normally it's a 0. I put like a 10 ohm resistor in there or something because it's not going to affect it because it's still got plenty of current. There's a 3-volt regulator there, or excuse me, there. That was burnt up. There was a diode up over here that was burnt out. Where is it? Oh yeah, that's the pack that was burnt out. That's like a protection diode. Crystal was good, but that's why it wasn't charging that. However, there was some other problems as well on the other side of the board. Let me swap over to that. And yeah, if we look in here, this regulator was bad. This here was another FET that was blown. This here was bad as well. That is this was drawing like quite a few amps through here, not a few amps, but several hundred milliamps through here. So removing that switching transistor made it go away. This is what controls the boot control line. And this protection diode here was bad. This is the thermistor. We thought that was bad. And let's see, that device was bad there too. We ended up changing that, but that wasn't actually the cause. So there's quite a few things here, and I believe it was all related to static, but the problem is it was manifesting itself as a kind of unknown, and you can see the battery right there, as like an unknown problem, but it was on the unswitched B plus side, which meant that this power switch doesn't actually do anything that's here. This guy, when you turn it and click it, it briefly energizes a circuit down here. Let's see, here it is. It briefly energizes the circuit until it's got a time constant in it until the CPU gets up and running. And then once that happens, the the switch has no effect after that. It's actually taken out of the circuit. That way, if you shut it off, the CPU detects it as a, actually on one of the analog inputs on the CPU, detects it as a low battery condition that's imminent, and begins shutting down the radio because it's below a certain voltage. So that's how it works. But we ended up having to take off because these, this is your driver and this is your final. Of course, had to take the shield off because these are connected through this here and this here. Let's see if I can get over here with it. Yeah, this coil right here and then this coil right here provide direct B+ connection to the driver here and the final. That's a one of their custom little chips in there. The other problem is on this side of the board we had this power control chip is directly connected as well. And then there was also, we did finally find the short. It was a capacitor in here. Well, excuse me, yeah, cap right there that was shorted out as well. So I don't know exactly what happened here, but there's a lot of stuff. And if I go up here, you can see some of the parts. These are not all the parts, but they are some of the parts. There's your regulator. What was interesting when we actually tested the FET out of circuit, resistance, everything was good on it. It matched a new one. What there was some slight leakage through it. So it wasn't a complete failure. I believe that was caused by electrostatic discharge. And if I go in here, I'll show the schematic here. So you have your essentially your crystal down here going into your CPU. I was going to say MCU. It's a 68HC11, and it's a very low power device. You'll actually see down here. Here's your unswitched B+. It has its own little separate, very low power dropout regulator on it. Goes through here. This actually shuts off the charging here if it's powered on. This was bad. This regulator was bad, and this device here, which handles the boot control, because this is on the standby side here. You see it goes, let me zoom out here, goes from here over to the Mod V standby, and of course that's where your boot control lines are when you go into bootstrap mode. So you need to have a way to take that out of the circuit. So that was the majority of the problem right there. It was definitely some sort of a, I'm thinking ESD, just because, again, this was only a partial failure, but there was enough leakage around it to cause a phantom 30 milliamps of, cause a real 30 milliamp draw here. It wasn't enough to heat anything up. It was just enough to say, hey, the radio is, instead of drawing, 58 milliamps, powered up, no receive, no nothing, just sitting there, no backlight on. It was actually drawing closer to 90, and when it had started, before I swapped this piece out, this was a dead short in here, and this was on the boot control line. This was actually taking about somewhere in the neighborhood of 600 milliamps, so it was drawing quite a bit. So there's definitely something wrong with it in that regard. But it was multiple things, and it was such a small amount of current that we can see. And because this stuff tested as a, it tested good otherwise, we ended up having to go through and just look at every single thing. I actually thought it might be something over here with the, if I zoom in there, I'll show you, hold on. Where is it? Oh. So yeah, so that chip right there, that's the, we actually look at it, this is connected directly to unswitched B+2 because, of course, the chip turns itself on, turns it off. Here's your B+, there and there, those two pins on it. So I ended up lifting those two pins just to get it off there. This is your, what is it, the audio AFSIC. This is your main power amplifier for your audio. It's one of the TDA 9 They're N398, whatever they are. It's a standard part. So I thought it might be that. It wasn't. Again, touch on the power control chip. Thought it might be that over here too. And that's a custom chip, by the way. Oh, this came out too. This is a current sensing, current limiting device here. That's like a 0.01 ohms or something like that, so they can see how much power is being used, or how much current is being drawn by the PA. This is just a ferrite bead, and you can see, hey, here's your power input, and it literally comes right off of it and goes into the power amplifier. There's your fuse there, another switch device there, and then, you know, looking in here, this stuff is connected directly as well. This is your synthesizer, and here is the VDDA. This is your 3.3 volt regulator for the analog side. I thought that might be bad, or that was drawing it. That'd be the logical place to check first when you have a high draw. That wasn't it, but all this stuff had to come apart, and, you know, had to be meticulously gone through. It is possible to fix anything. These are very serviceable radios. You again just need probably need a microscope if you're going to start working on this stuff, and, you know, some spare parts sitting around. This is actually, I'm going to scrape this off. This is the there it comes off. It's got the old stuff on there. This is just a piece of tin copper block. They use it for heat transfer into the case. You can see that's just a thermal paste thing. I'll put a new one on there after I reassemble this, but I got to clean up the board and put all this stuff back together first. So that's the oh, and of course, you know, during all this, I knocked off one of the where is it here? This guy right here. I had to put him back on. It just flowed off the board. There's nothing I could do. It happens. And these are actually different. These switches, the mechanical switches that are here, if you can see, these are different than what's in the other radios. And I ended up having a couple other radios to work on. One of the best things I had was this. This is a board from an EX, but it doesn't have all the individual shielding. It's almost the same in terms of board, but I mean, it is the same. There's your custom chip, there's your MCU, flash, RAM's in here somewhere, but there's no shields to get off. So I was able to pull parts from it. The part numbers are almost the same. Some of the stuff was different, obviously, but there's a lot of similarity between this Wearus radio and you know, even this is a UHF. This is very, very similar, but, you know, you can see there are some differences. There's same driver, similar arrangement in the analog side, but it is different. There's 16 parts on here, which is nice, because it does have these E filters, so I can use those if I want to modify a 220 radio. But this actually works, so I'm probably going to keep this as just a working example of a board in case I need to probe around again in the future. I don't know if it works for receive and transmit. I think it's got a receiver issue maybe, but it's you know, it's good enough to probe around on. But that's kind of what you have to do to work on something like this, and you can't really rush it, so it takes a lot of time. I've never really gone that far into all this circuitry over here and understanding exactly how it works, because frankly it doesn't fail. So I'm going to put that back together, and I'll do a final, after it's cleaned up, video of it all working. But it works right now. Again, this is why I don't charge for this, because if I had to charge this person whose radio it was, he'd throw the radio out and buy another one. You wouldn't fix something like this, and probably I wouldn't have spent time on it. Actually, I think he gave it to me about 6 months ago to look at, and I just got around to finally looking at it. And I probably got 10 hours, 12 hours wrapped up into the thing, just going through it, messing with it, getting pissed off, walking away, coming back. That's that's how this goes. Anyways, let me button it up here, and we'll take some more video once it's all put together and working. And see the clock stayed the same. Yeah, it's working. And I tested the boot before. I put a new one of these on. This unfortunately just got a little messed up when I pulled it off there. There's really not much you can do other than replace it. It's a typical high quality Motorola knob, but it's working. That's my battery. I keep that.